For decades, the red planet has been the ultimate trophy in the celestial hunt. We've sent orbiters, landers, and increasingly complex rovers to its rusted surface, all searching for one thing, a sign that Mars was once a living, breathing world. NASA's twin titans, Curiosity and Perseverance, have spent years drilling into the dust of Gale Crater and Zhurong, sending back breathtaking, high-definition postcards of a dry, frozen wasteland. To the casual observer, the verdict seemed final. Mars died 3 billion years ago, its oceans stripped away by solar winds, leaving behind nothing but a planetary corpse. But while the world's eyes were fixed on the American icons, a silent challenger was moving across a vast, overlooked northern plain known as Utopia Planitia. This is where China's Zhurong rover touched down, and unlike its American cousins, Zhurong wasn't just looking at the rocks on the surface. It was equipped with a specialized tool that has now changed everything we thought we knew about Martian history, the Rover Penetrating Radar, or ROPER. You see, NASA's approach has traditionally focused on surface geology and atmospheric chemistry, but the Chinese Academy of Sciences took a different gamble. They wanted to see what lay beneath the makeup of Mars, the hidden layers of history buried under suffocating dust. And in late 2025 and early 2026, the data from Roper's deepest scans finally reached Earth. The results didn't just surprise scientists, they sent shockwaves through the entire international space community. NASA had previously mapped Utopia Planitia from orbit, dismissing it as a relatively boring volcanic plain, smoothed over by eons of lava flows. But as Zhurong crept across the orange sands, its radar pulses dove 80 meters, over 260 feet straight into the ground. What it found was not solid volcanic basalt. Instead, the radar echoed back a chaotic, complex architecture of sedimentary layers. At approximately 30 meters and 80 meters deep, the Roper system detected massive horizontal bands of material that shouldn't be there if the volcanic theory was correct. These aren't just rocks, these are the geological fingerprints of massive, catastrophic floods. We are talking about surges of liquids so powerful they reshaped the entire northern hemisphere of the planet. But here is the truly terrifying part for NASA. The American orbiters missed this. Their sensors were tuned to the surface, blinded by the very dust they were trying to study. By the time the Zhurong data was cross-referenced with new 2026 orbital scans, the truth became undeniable. China had found a subsurface gateway, a clear record of a massive ancient ocean that didn't just exist, it thrived exactly where NASA said there was nothing but old lava. This 80-meter revelation is the first crack in the traditional narrative of Mars. It suggests that our maps are wrong, our timelines are flawed, and that the most important secrets of the red planet aren't sitting in a crater waiting to be photographed. They are buried deep underground, protected from the sun's radiation, waiting for someone with the right technology to dig them up. And as we're about to see, the deeper Zhurong looked, the more the dead planet started to look like it was merely in a deep, icy coma. For decades, the scientific consensus on Mars was as cold and unchanging as the planet itself. According to the standard model of planetary evolution, largely championed by NASA and the European Space Agency, Mars was a twin of Earth only in its extreme youth. The narrative was simple. 4 billion years ago, Mars had a thick atmosphere and rushing rivers. Then, about 3 billion years ago, its core cooled, its magnetic shield vanished, and the solar winds stripped the planet of its life-giving water. Since then, it's been a dead, dusty rock. But in early 2026, a joint report from the Chinese Academy of Sciences and international researchers from the Sorbonne and the University of Arizona dropped a bombshell that shattered this timeline. Zhurong's radar didn't just find sedimentary layers, it found hydrated minerals, rocks that could only form in the presence of liquid water. And based on the craters and the surrounding geological context, these minerals weren't 3 billion years old. They were much, much younger. The data suggests that massive amounts of liquid water were active in Utopia Planitia as recently as 750 million years ago. To put that in perspective, 750 million years ago, Earth wasn't a barren rock. It was already teeming with life. Simple animals like sponges were appearing in our oceans. While the first complex life forms were evolving on Earth, Mars, according to this new data, still had liquid water flowing on its surface or just beneath its crust. This isn't just a minor correction, it's a total paradigm shift. If Mars was alive for billions of years longer than NASA predicted, then the chances of life evolving there jump from possible to highly probable. It means Mars didn't die in its infancy, it may have had a full, long adulthood. But why did NASA miss this miracle? The answer lies in where they were looking. NASA's rovers, as sophisticated as they are, were placed in ancient craters, Jezero and Gale, specifically chosen because they represented the oldest parts of Mars. They were looking for the dawn of life. China, by contrast, chose Utopia Planitia, a low-lying basin in the northern hemisphere. Because it's lower in elevation, the atmospheric pressure is slightly higher, and it acts as a natural drain for the rest of the planet. When Mars started to dry out, the water didn't just vanish into space, it retreated to the lowest points. Zhurong's data shows evidence of massive, sudden floods triggered by volcanic heat or tectonic shifts that happened during the Amazonian period, a time everyone thought Mars was a frozen desert. These floods were so violent and frequent that they left behind layered sheets of sediment that are still saturated with frozen brine today. The 750 million year miracle suggests that Mars isn't a fossil. It's a world that clung to life for far longer than we ever dared to imagine. And if the water was there that recently, it raises a terrifying and exciting question. If the water retreated underground only a few 100 million years ago, could the life that depended on it still be there, waiting in the dark? NASA is now frantically re-evaluating their upcoming Mars sample return mission. If China is right, we've been looking for 4-billion-year-old fossils when we should have been looking for much younger and potentially much more intact biological signatures. The race for the red planet just changed from a history lesson into a search for a survivor. The discovery of ancient coastlines and younger water is a scientific triumph, but in the brutal reality of 2026, space exploration is no longer just about curiosity. It's about survival, resources, and territory. For the leaders in Beijing, the data from Zhurong isn't just a research paper, it's a gold mine. Because where there was once liquid water 750 million years ago, there is now something even more valuable for the first human pioneers: massive, accessible reserves of water ice. While NASA's Artemis program struggles with the shifting sands of lunar politics and budget cuts, China has been quietly mapping the ice highway of Mars. The Zhurong radar didn't just stop at identifying sedimentary layers, it penetrated deeper into the permafrost of Utopia Planitia. What it revealed was a colossal reservoir of dirty ice, a mixture of frozen water and Martian soil, extending for hundreds of kilometers just 15 to 30 meters beneath the surface. To understand why this is a nightmare for NASA, you have to understand the logistics of Mars. To sustain a human colony, you need water, not just for drinking, but for oxygen, and most importantly, for rocket fuel. Bringing water from Earth costs tens of thousands of dollars per liter, but if you land where the ice is already waiting for you, you've just solved the greatest engineering challenge in human history. NASA has known about ice on Mars for a long time, but most of it is locked in the polar caps, where temperatures drop to a lethal -150 degrees Celsius, or buried hundreds of meters deep in rocky craters. Utopia Planitia, however, is different. It's located in the Martian temperate zone. It's flat, it's accessible, and the ice is so close to the surface that a simple industrial drill could reach it in hours. China's 2026 strategic roadmap, leaked through academic channels, suggests that they aren't just looking to visit Mars, they are looking to stay. The Zhurong landing site was chosen with surgical precision. By confirming these massive ice lenses, China has effectively claimed the most hospitable real estate on the planet. While American missions are spread thin across various scientific targets, the Chinese National Space Administration, CNSA, is focusing all its energy on this one resource-rich basin. This is the real reason behind the sudden acceleration of the Tianwen 3 mission. Originally planned for later in the decade, China has moved the launch forward to 2028 with the goal of being the first nation to bring Martian soil and potentially Martian ice back to Earth. If they succeed, they will have a map of the most vital resource in the solar system, while NASA is still debating the funding for its own sample return mission. But there's an even deeper layer to this strategy. The ice in Utopia Planitia acts as a natural shield. On the surface of Mars, unblocked solar radiation can kill a human in months, but by tunneling just a few meters into these ice-rich layers, Chinese taikonauts could build pressurized habitats protected by meters of frozen water. It's a ready-made bunker system waiting to be occupied. The secret reservoir of Utopia Planitia has turned the red planet into a game of planetary chess. NASA is playing for the history books, but China is playing for the map. They've found the water, they found the shelter, and they found the fuel. As the 2020s draw to a close, the question isn't who will reach Mars first, it's who will own the gas station when everyone else arrives. The deeper we look into the radar data from Utopia Planitia, the more one haunting question begins to overshadow every scientific discovery and every geopolitical move. Is Mars truly dead, or is it just waiting? For years, the search for life on Mars has been a search for fossils, ancient dried-up remnants of bacteria that perished billions of years ago. But the 2026 Zhurong data has flipped the script. If liquid water existed as recently as 750 million years ago, and if massive reservoirs of ice still sit just 15 meters below the surface today, then we aren't looking at a fossil record anymore. We're looking at a potential cryogenic vault. On Earth, we've found extremophile bacteria that have survived for millions of years, trapped inside ancient ice and salt crystals. When thawed, these organisms didn't just wake up, they began to replicate. If the Martian environment transitioned from wet to frozen much later than we thought, the biological window for life to adapt and retreat underground was wide open. This is the sleeping giant of Martian exploration. The Chinese Academy of Sciences has been remarkably quiet about certain specific anomalies detected in the mid-layer sediments of the Rover scans. These are areas where the radar return shows unusual dielectric properties, pockets that don't quite match the density of pure ice or volcanic rock. Some astrobiologists believe these could be brine pockets, super salty liquid water that stays liquid even in sub-zero temperatures. If Zhurong has indeed detected subsurface brine, the implications are staggering. It means that right now, under the feet of the Chinese rover, there could be active metabolic processes happening in the dark. This brings us to the ultimate stakes of the 2028 Tianwen 3 mission. While NASA's Mars sample return has been delayed and redesigned due to ballooning costs, China is moving with industrial speed. Their goal isn't just to bring back rocks for geologists to study. They are targeting the very layers where Zhurong found evidence of young water. They are looking for biosignatures. Imagine the global impact if China returns the first samples from Mars and they contain dormant Martian spores. It wouldn't just be the greatest scientific discovery in history, it would be a total shift in how humanity views its place in the universe. It would mean that life is not a terrestrial fluke, but a planetary constant. But there is a darker side to this race: contamination. If China or the US breaches these underground reservoirs without extreme caution, we risk forward contamination, introducing Earth bacteria into a Martian ecosystem, or worse, bringing something back that our own biosphere isn't prepared for. As we stand in 2026, the silence from NASA regarding China's latest radar maps is deafening. Behind closed doors, there is a scramble to catch up. The red planet is no longer a distant dream for Elon Musk or a laboratory for NASA's rovers. It has become a front line. Zhurong has shown us that the dead planet narrative was a blindfold. Mars is a world of hidden oceans, recent floods, and perhaps silent inhabitants. The technology of the 21st century has finally allowed us to peel back the dust and see the truth. The race is no longer about who will be the first to plant a flag in the red sand. It's about who will be the first to reach into the ice and wake the sleeping giant. And right now, in the quiet expanse of Utopia Planitia, China is already holding the key.